here's where we left off yesterday. We found out that the x value is also known as the cos of our angle of rotation, and the y value is also known as the sine of our angle of rotation. And we got those from doing some trig. But remember, trig is not the only thing that can be done on a right triangle. We could also do Pythagorean theorem. A squared plus b squared equals c squared. And on my triangle there, the right triangle, one of my legs is cos. So for A, I'm going to do cos theta squared. For my other leg, it's the y value, or my sine. So I'm going to do sine of theta for B, will be squared, is equal to the radius squared, which in this case is 1 squared, or just 1. And this is known as one of the Pythagorean identities. And this tells me for any angle that I pick for theta, if I do the cos of that angle squared plus the sine of that angle squared, I am always going to get 1 as an answer. Check it out with your calculator. Let's just pick a random number for theta, let's say 54. So we're going to do cos 54, parentheses, square that, there's my cos squared, plus sine of that same number of degrees, 54, parentheses, squared, and hit enter. The answer comes out 1. No matter what angle you pick, you could have picked 3,540,000 and done cos of that squared plus sine of 3,540,000 squared, and you would get 1 as an answer. Now, not only is that kind of amazing, it's also helpful to us. Because let's say I am given the cos of some angle is -3/5, and I want to figure out the other 5 trig functions, trig ratios, without having to draw a picture. So if I know cos, obviously then we know secant is just the reciprocal -5/3. But if I use our Pythagorean identity, I'm going to be able to figure out sine of theta, because I can substitute in what I know about cos theta. I know it's -3/5. And now I'm going to apply one of our properties of exponents, one of our laws of exponents. This whole fraction, numerator and denominator, are going to get squared. -3 squared makes 9. 5 squared is 25. Now we'll do some algebra. I need to get the 9/25 away from the variable from our sine theta, so I'm going to subtract 9/25 from both sides. And 1, or aka 25/25, take away 9/25 is going to make 16/25. That's going to equal my sine of theta squared. Just like at the end of Pythagorean theorem, you have to square root to get rid of the square. And the square root of sine squared is just going to cancel out the squares, and the square root cancel out. And the square root of 16/25 is the same thing as the square root of 16 over the square root of 25. And bam, sin of theta is 4/5, which would then tell me cos is the reciprocal of that, 5/4. And then we could even figure out tan and cot, because tan, as we learned a couple days ago, is the same thing as sine divided by cos. So if I take my sine and divide it by the cos, 4/5 divided by -3/5 makes -4/3. And then I would know that cot is the reciprocal of that, -3/4.